Hello, everyone, and welcome back to Infrastructure Matters, episode 69. Wow, it's been a pretty interesting year so far. It's been lots of revelations on AI and new administration, lots of executive orders. But let's get right into the news. So I think we're talking about IBM had a very interesting, IBM or IBB, what is it?
IBM. That was my mistype.
That's what I thought. I've absolutely been loving what they've been doing with AI on in terms of enterprise class models with their Granite model, the new 3.0 version. So I've watched that closely, but I haven't been tracking the earnings. So Camberley, can you catch us up?
Yeah, so they did very, very well. I mean, it's not like 20% that we saw with another firm, which was Commvault, but it's IBM, and some very big is revenue growth of 3%, 12.7 billion of free cash flow. Arvind talked a lot about where they were in 21, where they are now, of setting the plan that they had for mid single digit growth, and they delivered that, which is a 6% CAGR over that period. What really grew was their software. That business has grown significantly, driven not just by Red Hat, because over the last few quarters we've been talking a lot about the Red Hat stuff, but also about their AI initiatives with Watson, et cetera. Those have all done very well, as has transaction processing. And as people know, I keep talking about the mainframe. It's not dead, and boy, it's not dead. This year, they'll be releasing the next generation of the Z. And a couple of things he said. This is the 11th quarter of the Z16. After 3 years, I'm quoting exactly 3 years in, this product has outpaced prior cycles and program to date, with over 30% of the client increased over 30% as clients' capacities continue to grow. And that, I think the number that they quoted was 60% or 70% of their clients have increased their capacity. That's also driven into some of the things that are going on there is, the AI work that's going on with transformation of the COBOL technology. So expect this next year, as they release the next release, is going to be astounding well. The other thing that I loved what they said, and they have had a huge momentum with Red Hat. Fourth quarter was 17% growth. So they continue to do double-digit bookings. But one of the things that they alluded to is that some of this is getting driven by VMware. They didn't say VMware, but they said they continue to see the increase of the OpenShift virtualization engagements. And they didn't quote a number there, but so you and I, we've all been talking about how much is this happening? Are they really getting off of it? Is this really changing? And of course, IBM is in the core enterprises. That is and
their hybrid cloud offering is quite popular. And at their recent analyst day, I think some of us attended. They were real clear that they had a migration offering to make that easier. Mm-hmm. Some CIOs wanted to take them up on that.
Yeah. So that's done really well. So expect, next year they are expecting a banner year. I mean, they've got a huge book of business on the AI side of the house, is both on the software and the consulting business that's going on. The only thing that so I'll stop there, but that's really good.
No, I just finished a major piece of research looking at all the different agentic AI frameworks and solutions, include Watson X was included in that. And they came out, they scored, I think, number 2, number 3 across the whole field. And this is a stark departure from, kind of their very flaccid results with Watson way back in the day. Keith has, looking at all these results and, people wanting to put their, run their cloud on IBM and use their AI, is IBM back? This is, they seem like they were heading towards the long good night,
Yeah, I think IBM has always had a seat at the table, right? The they bought PwC's legacy consulting business. And so they've always been strategic. When you have a RFP for an ERP solution, IBM is going to be at the top of, if not providing the actual solution, implementing and process change. I've long said that the value of AI is in the ability of solution integrators to be able to help with the change. And IBM is just, they have it within their fabric to understand both the technology and the process change needed. So it's not a surprise. I think a lot of us who've watched the industry for a long time have said that IBM is probably one of the best incumbents positioned to capitalize off of AI. And we're starting to see them get out of their own way, quite frankly, and telling their cloud story and their end-to-end value prop.
One of the line items that Arvid talked about, I think it was him that responded to the Q&A from the investors, was that they talked about the smaller models. And I think this is a little bit of, we're going to talk slightly about DeepSeek, so you may want to go to that now. But talked about the value of the smaller models and that they have seen a 60% cost or efficiency number and using the smaller models for inference engine and inferencing. And, that's, all the noise on the DeepSeek things is what the cost about it was. I mean, we talked about the speed of it, but what the cost around it was that we talked last week. And this is, again, that innovation that we're going to see is going to drive down the cost of delivering of what we're doing with AI. And I think IBM has, definitely is in the game.
Well, that's their value prop, is they say the Granite 3.0 has got very close to the performance of the top models, but at 1/10 the cost, right? So we see that IT budgets right now are ballooning because of the expectations around what it takes to run AI, and so IBM is saying, "Hey, you don't have to take that hit if you work with us," which I think is a really smart move. Although I think trying to get to the top spot based on pricing is not necessarily always the smartest move.
Yeah, and again, I want to reiterate that inferencing is not going to take the GPU and power requirements of training. I think we just did AI Field Day 6. I should have put that in the rundown. But as part of AI Field Day 6, we talked to VMware, Memverge, and a small company, Kamawaza, that helps us internally with some of our Signal 65 testing. And the consistent theme is coming out that customers are still asking the question, how many GPUs do I need? We'll get into DeepSeek. But I think IBM, granted, is doubling down on this idea that, on training, yes, you're going to need the multiple megawatt or the 1 megawatt rack at some point. But for inferencing, small models, more traditional air-cooled systems are what is probably going to win the day in the enterprise.
Yeah, well, let's do Seagate real quick, and then let's dive into what's happening with DeepSeek.
Well, there was two companies that announced earnings in the last week on hard drives, and I bring that up also because I talked about mainframe, which is not dead yet. HDDs are not dead yet either, and that was Seagate and Western Digital. Seagate's stock had a big jump from it, and it's kind of like, who cares about HDDs? And WDC was kind of like not that great because they have two parts of their business. One is the flash side, which is not doing well, and the other is the HDD side. So why are HDDs still in play? Because all the enterprise, if we're talking the enterprise, they're migrating to, solid state. Well, it's a big portion of that is what's going on with the cloud. And so much of the data is on HDDs. They are not moving off those devices. And they are shipping them. So talking about, as soon as they start talking about opening more data centers, well, that's going to, they're just rolling them into big, huge racks of HDDs. I've got a friend of mine that's a sales sales rep for them. And we talk about, you're just going to roll these big, huge racks of drives in there and they're going to, deploy them themselves, et cetera. So that's what's happening there. It's not dead yet.
Yeah. I think they got a little bit of life left in them, given their huge patent portfolio and storage and things like that. So,
yeah, but we're also saying the enterprise is still buying hybrid systems. I mean, I just had a call with NetApp, and they were talking about, their hybrid systems, the solid state and hard drive for secondary storage is still very alive and well. I think it's well over 50% of their business still in terms of that, the on-tap arrays that they're shipping. So,
well, I think we really forget. I mean, I was just talking to some CEOs in the Midwest, CIOs in the Midwest, and it was surprising how very much in the 2000s they still are, right?
So if we dig into it, like computers becoming dense, we're seeing it in GPUs, et cetera. And the one of the things that we're battling from an architecture perspective, how much do I sacrifice in space? Obviously, SSDs are denser than HDDs, but from a practical perspective, if the rest of my computer's shrinking, what do I care about performance, energy cost, et cetera? There is a argument that if I have excess rack space and HDD costs are lower per terabyte than SSD, okay. So this is something that I think we'll have to ping our Signal 65 peers on. Where's the value? Where's the real value point of SSDs versus HDDs, and help customers make better purchasing these decisions? Because I don't think this is a obvious, price per terabyte question. It is a question of, how much is it costing me and what's my operational overhead to run one stack over the other.
Well, you could get Mitch Lewis on here from Signal 65 because he's done that some of that analysis, and it's an interesting analysis in terms of what you can pull, what you can do in the data center. So yeah.
Yeah, well, we're talking about data, and the big saga from last week is still ongoing, and that is the arrival of highly capable frontier model that apparently doesn't take a lot of compute to use. The whole question now still centers around how did DeepSeek create its model, and that's the huge debate. And some data came to light that 20% of all of NVIDIA's GPUs go to Singapore, which is probably highly unlikely. And that's probably the vector. That's the forward shipping location for GPUs into China, and so that's been top of mind for a lot of folks because it's really greatly impacted the stock market, VC investment, a bunch of things in terms of where AI is really going to go, and it's becoming clear as we really analyze. DeepSeek didn't use CUDA. That was, I think, one of the most interesting revelations. They went bare metal for their AI stack, so they could do all kinds of super optimizations to make inference really, really cheap. The list, I'm tracking the list of the optimizations that DeepSeek has on AI, and it keeps getting longer and longer. A lot of it's because they said, well, we're not going to use that. We're going to do really extreme optimizations in our use of these GPUs to squeeze out every last bit of capability. What are you guys seeing in terms of how DeepSeek is kind of recalibrating the AI landscape?
Yeah, one of the things that I'm paying attention to is, again, the inferencing from a technical level. Really interesting tweet or X post, whatever we call tweets anymore on Twitter, is one of the engineers, at large engineers, posted the configuration for running DeepSeek on dual processor AMD EPYC CPUs. So DeepSeek is memory bound. So we talk about the importance of GPU versus CPU architecture. And it seems that the biggest factor is in its recursive way that it does reasoning is the amount of RAM. So this, 700 billion parameter model acts like a 45 billion parameter model. So you can run it on systems with less oomph. This gets you about, this dual CPUs, air-cooled system with no GPUs, 768 gig of RAM, looks very much like a typical virtualization server. I have them in my lab, can run DeepSeek at about 10 tokens per second, which is not pretty usable from a production perspective, but from a lab perspective, very achievable. You put Luke Norris from Kamawaza noted that if you ran this on one of the Digix developer platforms that NVIDIA announced we covered a few weeks ago, you can get a few thousand tokens per second with DeepSeek. So that is, O1 level, a GPT O1 level.
Let's say you run top of the line AI
Right.
on a single machine and right in front of you, right?
That is on your desktop. That was essentially a desktop. That is game changing, which goes to the argument around what IBM is saying around Granite. You don't need, for a trusted model that does the job for your limited use case, you don't need big GPUs to do this.
And that's the thing. What I think I said this last week. Scarcity is a mother of invention. And when when things are scarce, we now also, we start optimizing. What you were talking about. What are they? You're going to look at all the areas that you need to optimize in order to deliver on. And so, this is we're going to see that in many, many places, especially as we saw, the dollar signs on this. My concern around that is, what does that mean to these forecasts that we're having about how much it's going to drive? Well, then I go back to saying, I can remember when we would start shipping PCs or whatever with this massive capacity. How you would ever use all that capacity? Well, we always do. One, scarcity is a mother invention, and we will use whatever capacity we have. Darn it, I used all my closets in my very, very large house.
Yeah, I think that's a great proof point. I mean, the real issue is going to be is how long is DeepSeek going to be with us? Just because, Italy has now blocked DeepSeek, the Department of Defense has blocked DeepSeek, and it may be hitting the way of TikTok. Because. Yeah, go ahead.
I think the big difference is that you can run it locally. So unlike TikTok, unlike some of these other Chinese platforms, it's open source. I can just download it and run it and, on my desktop, literally.
You
so
sure it doesn't have a call home button?
Well, that's
sure it doesn't have a
the
call
word.
home button you don't know about?
Well, we have some pretty good computer scientists here. We'll figure that out. But I don't think users are really worried. There's 100 million TikTok users in the US. I don't think we really worry much about our data being exfiltrated to the CCP. We probably should, but we don't.
Yeah, well, it's going to be it's the big story for 2025 in AI for sure. Is this the long expected commoditization of generative AI, and this will force a real rethink. We talked about Project Stargate, $500 billion to train these models, and so if they've got the shortcut to creating these very lean, do lean training, lean inference, it's going to change a lot of things, and it could put China in the leader position with AI by the end of the year. That's the real concern, I guess, in a lot of quarters. All right, let's move on to other news. So Intel, speaking of chip companies that have had some challenges recently, they had some delays and some product cancellations announced yesterday. So Falcon Shores, which is Intel's much touted XPU, which is a combination of CPU and GPU and a single unified package, They decided not to run with it as a product. They're going to only use it as a test chip inside the company. And this has raises a lot of questions about Intel's capability in terms of really competing in the AI era. So I don't know, Keith, do you have any reaction to that news in particular?
Yeah, I think the architecture has promise. The big GPU farms that, again, we see in Meta, we see in Xi, and we see in across all of the big producers or models, we're not going to replicate that in the enterprise. So we need something in between. A small service provider actually in Australia noted that after DeepSeek, they saw a doubling in requests for AMD accelerators based on the demand for DeepSeek. I think we are going to see these market shifts on how we use accelerators in a data center, whether these are on chip. I think CPU on chip accelerators, while stuff like running DeepSeek on two Epic or Intel Xeon CPUs is interesting. It's not what's going to happen. We need some combination of accelerator and CPU. And I think Intel is deciding that Falcon Shores isn't it. I hadn't even heard of it until it was killed. But I do believe Intel is going to return back to its days of the specialty ASIC, the programmable ASIC combination of that and CPU. It was the right model, probably a little early, but I think we'll see the return of it in some way.
Well, I've been bullish on FPGAs for a long time, just because they have such potential to create a hardware performance for software-based applications. The problem is it's very hard to develop for them. Just like multi-threading was so hard to develop still is hard to develop for a lot of folks that take advantage of these super high core CPUs, which is the other news. Intel has delayed Clearwater Forest, that's their Xeons, on the 1.8 nanometer process, which is just amazing to me. I don't know how many more nanometers there were to shave off the process. That's astounding. And I don't think it was entirely unexpected. Their current Xeons have 288 cores, or the versions that'll be released this year. So that was bringing it a little bit close in. If they were gonna ship this the first quarter of 2026. Now it's pushed off to later in 2026, and might be even later than that. But that is an amazing advance that that Intel's bringing on the ultra advanced process ahead of much of its competition. So let's talk about Camberley. You had some news around edge computing infrastructure. Want to tell us a little bit about that?
That's actually Keith. He's running with the edge stuff.
Yeah. So
The edge.
Elon Musk, and we don't miss Elon Musk on this podcast, but Elon announced or mentioned that unfortunately, if you bought a Tesla pre 2022, 2023, and you were expecting full self-driving FSD, you'll need to upgrade. The computer system originally was hardware 2.0 in the 2016 model, hardware 2.5, then 3.0. Been a lot of controversy around this promise of kind of full self-driving being able to be just a software download. Well, evidently it's not. It is. It requires a hardware upgrade to hardware 4.0.
So infrastructure matters.
So infrastructure does matter. So it is a question about an example of life cycle. While I'm bullish on the idea of running DeepSeek on CPUs, that's probably a little bit aggressive to what's going to actually happen at the edge. So as we push AI further out to the edge, we really need to consider what is our life cycle strategy around managing those physical components, because as we depend on our business processes being enhanced by AI and more compute at the edge, software will eventually outstrip the hardware.
Do you know why Tesla is saying you have to upgrade I guess, swap out the hardware that's in there and what.
Yeah, they underestimated the hardware needs of FSD. I think this is yet another lesson. This is something that, as advisors, we always talk about. Don't buy hardware or software based on the potential what it can do, but the value that it adds today, because that potential may never come throughout the depreciation life cycle of the equipment. And this is just a classic example of buying on a promise versus buying on the actual capability.
So I'm assuming what this was is the processing power was not strong enough.
It wasn't strong enough
for the amount of data that they're going to need to process, whether it's memory or processing power or whatever that's going on there. Okay.
Yeah, whatever CPU that's needed to process the real-time data coming from off the cameras, it just wasn't enough based on, their continued development of FSD software.
So that gets us into, we've talked for many years, and the market has talked about the software-defined data center, like the software-defined world. Everything's software. And it's kind of like, yes, but you still need to have the oomph behind it to drive it. Literally in this situation.
Well, and this is why I've been fairly bullish on FPGA, because what if you could recompose the hardware? That's the thing. If you come up with superior designs, you can just reprogram everything down at the right on the chip to run more efficiently without having to ship new chips. So that's if you're doing really software defined, that would be the ultimate potential. But we're not there yet. And I'm glad to see you can actually recompile C code now into FPGAs pretty easily. But it's interesting.
And DeepSeek is that example, right? They bypassed the abstraction layers of CUDA. CUDA is very convenient for developing platforms on top of NVIDIA chips. And these researchers said, you know what, we're going to go the old assembly level language map route, and we're going to program directly to the hardware to get out every inch of efficiency. So 100% efficiency versus 60 to 70%. 70% would be outstanding for GPU performance. So they're claiming 100% efficiency. So from the networking, storage, and compute capabilities, you can only do that by going as low level as possible. And to your point, Dion, FPGAs allow you at least the option to do that.
So this gets into, because I think of the life cycle of what you're talking about with Tesla. We're only talking, are we getting into a point now we're looking at a 3-year life cycle on this? That's costly. Then I have to look at an ROI very, very differently, because I've been typically on any kind of server deployment. I'm looking at usually, is it 5 years on a server? Or is it
5 years? So the 5 years before the server becomes free. That basically, we sweat those assets for as long as we can. If it's running and we have support on it, why accumulate additional depreciation costs? And I think to your point, the bigger point is lifecycle management. We've set up our environments in which we can switch out this hardware on a rolling 5-year schedule. If now I have to go down to 3 years or less, that's a good challenge for the enterprise.
Right. And I start to think about, okay, so what use cases are we talking about this hitting? Okay, let's start with retail. And, I've worked retail. I understand, the pain of doing an upgrade into all those stores. You're talking thousands of stores or something. I'm Home Depot. I'm implementing.
If you want to move to, let's say, the AI powered, checkout-less checkout, which is you can just grab the items and go out, but that requires spatial recognition, item recognition, a connection to the ERP system, all those types of things in real time, and that will consume a lot of power. That's the kind of use case we'll say that's a step function up to a whole new level of compute for an average retail organization.
Yeah, it reminds me. I need to reach back out to the chief architect of Chick-fil-A. A few years ago, they rolled out Intel NUCs to run Kubernetes at every store. So every store was a software platform. Well, that's the Intel NUC is not even offered anymore. So how are they managing that platform lifecycle out at the edge? Is a really it raises a really interesting question.
Yeah.
More to do. So, well, that brings us to time for this episode. And so thanks for sticking with us this long. Next episode's episode 70, and we'll see you next week.